Hey guys, here are the notes for Monday 4/27 to Tuesday 4/28. All right, this is lesson 13 back when we've been kind of bouncing around, in chapter 13. But today we're going to go back to 13-1 and talk about exploring periodic data, okay? All right, so this is very important leading into the sine and cosine function and all that good stuff. All right, so see if you guys can follow these notes. It gets a little bit confusing, so you may have to pause or go back and watch it over and over again. But again, if you have any questions, just let me know. Okay, all right. All right, let's fill in some blanks, some vocab, very important, okay? All right, so a periodic function is a function that repeats a pattern of y values, okay, your outputs, at regular intervals, okay? One completed pattern is called a cycle. Okay, it's very important that you keep these terms separate in your mind, all right? So a cycle is one completed pattern. A cycle may begin at any point on the graph of the function, okay? Okay, the period of a function is the horizontal, okay, left and right, length, the distance along the x-axis of one cycle, all right? I'll show you what that looks like here in a second. The x value in a periodic function often represents time, okay? All right. Periodic behavior is behavior that repeats over intervals of constant lengths. All right, look at problem number one. And guys, I apologize for these being so small. I couldn't find bigger examples here, so I'll kind of zoom in, all right? All right, this one says, analyze the periodic function below. Identify the cycle in two different ways. What is the period of the function? All right, so first of all, we know that this is a periodic function or periodic data because look at it repeats over and over and over and over again. It's the same wave if you want to think of it that way, okay? And like we said before, a cycle can start at any point on the graph. If you look here where it's in red, this cycle begins at 2, all right? On the x-axis. So it starts right there, and that x-coordinate of that point would be 2. All right, follow the red part, and it ends right there. That red part is one cycle. If I were to take that and slide it over, it would match up perfectly to that spot. If you kept on sliding it over, okay, for example, that right there looks just like that, which looks just like that, okay? That's what we mean by a repeating pattern. All right, so this is periodic. All right, so we would say that this in red is a cycle. That's one cycle. Now the length of that cycle is referred to as the period. Okay, so if you look here, okay, the period starts at 2 and goes until 6. All right, so one cycle starts at x equals 2 and ends at x equals 6. So 6 minus 2 is 4. So the period of this function would be 4. Okay, remember, this is where it gets confusing. The period is the length of that cycle. If we went over here and looked at this one, this is another way to represent a cycle right here. All right, I could start here. This one starts, I believe, looks like 8, okay, and ends at 12. Well, once again, 12 minus 8 is 4. It's still, the length of that cycle is 4. But we represented the cycle in two different ways. There's one, and there's the other way. Okay? All right, so we identified it in two different ways, and we identify what the period was. The period, again, is the length of that cycle. All right, let's see if you got it here. analyze each periodic function, identify the cycle in two different ways, and what is the period of the function. Okay, so it doesn't matter where you start. So for this one, I could start right here. All right, looks at like at -4. And if I follow this around and I stop right there, that is one cycle. So I went from -4 to 0. All right, so we would say that the period is 4. All right, and if I had to represent it, I don't have another color here, but in a different way, okay, I could start up here and go down and around and stop. Just like that. Okay, so I represented, there's one cycle there, and this time I started up here, and there's the other cycle. So I represented it in two different ways. And again, the period is the length of that cycle. I went from -4 to 0, so the period would be 4. All right, over here, again, you guys, I'm sorry, this is kind of small. All right, if I want to identify this two different ways, I could start here, up, and then stop. That would be one cycle. Okay, because if I move that over, it would match up here and match up there. And then I could also start down here if I wanted to. Okay, and I could go like that. Oh, you know what? I would just go from here to there. Okay, so let's see what this is. Let's say -1, -2, -3, -4, -5. All right, it looks like I'm going all the way to -2. So from -5 to -2. So we would say the period is 3. All right, once again, we identified the cycle. There's one cycle and there's another cycle. Okay, identified it in two different ways. And the length of that cycle is the period, which is 3. All right. All right, let's look at page 2 of our notes. All right. Let's see here. It says identifying periodic functions. Is the function periodic? Yes or no? All right. Now, if we were in class, all right, I guarantee half of you guys would say yes, that this is periodic because it looks like it's repeating. However, okay, you notice it's repeating, but it's going down. All right, we're not repeating the same y values over and over and over again. So this one is actually no, that's not periodic. This one, B, this is periodic, okay? So as the x values increase, my y values do the same thing over and over and over again, okay? All right, so we can see here if I started here, followed this around, and ended right there. That would be one cycle. All right, so yes, this is periodic. And the period, again, remember, the period is the length of that cycle. So it looks like we're going from -1 all the way to 9 or 8. I'm sorry, this is 2. Okay, so this would be -2 because it looks like we're going by 2. 2, 4, 6, 8, 10. So from -2 all the way to 8. So that period would be 10. Another way to see this, yeah, I should have got a different color. Yeah, I could have started here at 0. And if I would have went, that would have landed me here. Okay, from here to here, that's from 0 to 10. So again, the period is 10. All right, okay. Is the function periodic? Okay, this would be a no, because the y values are not repeating. Okay, B, yes, this is periodic. Okay, all right, and the period would be, let's start here at 0. Go up and stop right there. So it looks like 1, 2, 3, 4. So the period for that would be 4. Started at 0 when x equals 0, follow that around. Okay, and again, that's one cycle, and the length of that cycle is 4. Okay, All right, so far, guys, we have two really important terms. We have cycle and the period, okay? All right, we have another one. All right, this is the amplitude. Okay, the amplitude of a periodic function measures the amount of variation in the function values. Okay, so look at, all right, it kind of measures the height, okay, of your periodic function from the midline. All right, so it's very important. All right, if you notice on this graph, we have the maximum y value, we have the minimum y value, okay, and halfway in between those is what we call the midline. My amplitude is from the midline, okay, to that maximum point, or from the midline to the minimum point, okay? Either one, that's my amplitude, okay? All right, the midline is the horizontal line midway between the maximum and the minimum values of the function. The amplitude is half the distance between the max and the mid. So you guys, all right, this right here, if you have to find the amplitude, okay, which you will many, many times, this is a little formula that you use. You take 1/2, and you're gonna multiply that times the maximum value minus the minimum value. So you take that first, multiply it by 1/2, or take half of it, and there's your amplitude. All right, let's see if we can actually do that. All right, problem 3, find the amplitude in the midline of a periodic function. Okay, so if I'm looking here, my maximum, okay, my maximum point of my graph is these points right there, and they all land at 4 on the y-axis. The minimum, okay, if I'm going up, this graph goes up by intervals of 2, so 2, 4, 6. So this would be -2. Okay, so this distance here we're looking for, okay? Now, so to find the amplitude, okay, we're gonna take, so I'll just use A for amplitude, we're gonna take 1/2 times that maximum value, 4, minus that minimum value. Now be careful, because you gotta subtract that -2. So this is gonna be 1/2 times 4 plus 2, so 1/2 times 6. So in this case, my amplitude is 3. Okay? My amplitude. If this distance is 6, my amplitude is half that. So the amplitude would be 3. Easy. Okay? Easy. All right, just a few more here, guys. All right, what is the amplitude of the periodic function? What is the equation of the midline? Well, we're just gonna find the amplitude right now, okay? All right, so let's look at my maximum. And it looks like this goes up by 1, so my maximum value is going to be 1. My minimum is going to be -2. So here we go. My amplitude is 1/2 times 1 minus a -2. So 1/2 times 3. So that comes out to 1.5. So the amplitude of that graph, remember, the amplitude is from that midline up to the maximum or down to the minimum, right? That's the amplitude, so it's 1.5. Same thing with this one. If this is periodic, you can see that it repeats. It looks like if this is 4, okay, this is 2, so my maximum is 3, my minimum is 0. So my amplitude is going to be 1/2 times 3 minus 0. 1/2 times 3, it comes out just like the other one to 1.5. Okay. Okay, again, guys, the amplitude is that distance from the midline all the way up. Okay, all right, and we're gonna not do problem number 4 All right, so just to kind of go and review a little bit, you guys, a couple things that you need to make sure, all right, that you get from this lesson. All right, number one, what is a periodic function? A periodic function repeats, okay, the same pattern. It's like a heartbeat, right? It repeats over and over and over and over again. It keeps going on forever. All right, a cycle is one length of the pattern, all right, that repeats. All right, it's one completed pattern. That's the cycle. The length of that cycle, how we describe that cycle, is called the period. So we have cycle, we have the period, all right? And then we also have amplitude, okay? So just to kind of remember, amplitude from the midline up. The biggest mistake that you guys will make, or that I'll see, is you take that the whole distance from the max to the min is the amplitude, and that's not the case, all right? So if you have a straight line like that, and you're going up to a certain height and down to a certain height, and then up to a certain height, and then down to a certain height, right? So that amplitude is this distance that you're traveling, okay, from here to here, or from there to there. These will be the same if this is the midline, okay? So period, cycle, and amplitude, all right? So hope you guys got a handle on that. Your homework, if I can find that, it's in your packet, you guys. Let me see, I just had it here. All right, so your homework is going to be right here, 13-1. It should be in your packet still from when before we left school. All right, if you have that, you're gonna do obviously 1 through 8. All right, and you can finish up through, just do through 13, okay? You don't have to do 14, you can do through 13, okay? All right, guys, get that done, and please, please, please make sure you show your work, you guys. You remember, okay? No work equals no credit. Some of you guys, even when we're not in school, you're still driving me nuts, okay? I don't want you guys to take a picture of all the answers and shoot them to me. Please make sure that you guys are showing your work, and you can do your work right on here. That's fine, okay? All right, guys, have a great day.